I did not know I was still mute. I've just discovered that I was still mute, but I hope everyone can hear me. I was saying good morning to everyone, and I hope everyone is well. Right. So I was saying that from our journey from the start of the week, we've been doing revision, and we've been covering concept after concept, from multiplication to division to the word problems. Now we are at the shapes, and we are closing off what's left so that you guys are prepared. You guys, if you look at the newsletter, this is very important information. If you go to the newsletter, right, the one that has been recently released, you'll find that you guys are all writing on the 21st. I think it's the Tuesday. It's when it's you guys your time to write. So it is a time whereby now your parents will be able to go on the website and download the test, and then you do it there at home according to your pace. So it's very important that you pace yourself and you see what do you understand, what don't you understand. Whether you still clued up on multiplication or not, whether you still clued up on division or not. Do you understand the whole division process? What don't you understand about the division process? And how best to start improving? Because if you go through this whole test period without changing also the way you see maths, or without some change within you, then it serves no purpose. You need to have some change, and the change needs you to see maths in a different way, because it's a skill. So you forever want to find the best way of developing a skill. And the best way of developing a skill is going through constant participation and changing the lives of others. So this skill that we are trying to nurse of maths, let us try our best to protect it and always speak when we don't understand anything. Right. So when we're looking at, as I always say, guys, here's my email address, and here is my Twitter handle. My email address and my Twitter handle. Please, 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 please. If you find yourself not understanding and you need help to enrich the skill of maths, please do contact me. If you find yourself lost, please do contact me. If you find yourself not understanding anything and you just need that extra support, please do contact me. Right. So here is the test scope. I'll give you guys about 2 minutes to put this down, and then we start the lesson. So I'll give you 2 minutes to write down the scope, and then we start the lesson. 2 minutes starts now. So you can screenshot, screen grab, but that's your that's your scope for the test. Multiplication, 2 and 3D shapes, division, word problems, and addition and subtraction. So there's the test scope. One minute, 10 seconds left. 1 minute, 10 seconds left. 50 seconds remaining. 50 seconds remaining. If you are done writing down the scope, then you can also you can, if you are done, you can quickly just tell me to the chat, and then we're able to go through the next slide and cover the parts of information and everything. So please, 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 if you are done, please do notify me through the chat. Please do notify me through the chat if you are done writing down the scope. If you are done writing down the scope, please notify me through the chat. Please notify me through the chat if you are done. Right, I need just some notification of who are done with writing down the scope. But because it's not the first time you guys have had it, I'll just move right along. So we're looking at the description of 2D and 3D shapes and the line and what a line of symmetry is and the nets of 3D shapes. That's what today's lesson is. So in geometry, a two-dimensional or 2D shape can be defined as a flat plane figure or a shape that has two dimensions, namely length and width. Two-dimensional or 2D shapes do not have any thickness and can only be measured in two faces. So 2D shapes are normally flat shapes, are flat like paper, such as your rectangle, your squares, your triangles, and they only have two dimensions, which is length and width. So they can only be, if you know, if you are at the stage where now you calculate the area, you can only use the two dimensions, which is length and width, to calculate the area. So those are your two-dimensional shapes. Your flat shapes are your two-dimensional shapes. I'll give you guys 2 minutes to get this down. If you're using a smartphone or something, please screenshot or screen grab. But if you are writing with pen, please write. Please write as quick as possible. It's flat shapes, most flat shapes. Most flat shapes. If you want to think about it, your windows are 2D shapes. Your windows are 2D. You know, anything that is flat, it's 2D. Uh, 1 minute. 1 minute. About a leaf left. About a minute left. Who's done? Please notify me in the chat. Who is done writing or having the information down? Please notify me in the chat. Please notify me in the chat. If you need more time, also please notify me in the chat. Please do notify me in the chat. If more time is needed, please notify me in the chat as well. Please notify me in the chat. Okay, it's good. I see a lot of people are done. Means that it wasn't challenging at all. Just a few more seconds and then we move on. Then we move on. I'll add, as there's a request for some time, I'll add 2 more minutes. I'll just add a quick 2 minutes. But please, if you can screenshot, please screenshot. If you can screen grab, please screen grab. Please use the technology as much as possible. Please use the technology as much as possible. Please sincerely use the technology as much as possible. Please use the technology as much as possible. One minute left. 1 minute left. 1 minute left. After this, I go to the next slide. 1 minute left on this information. After this, I move on to the next slide. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So, there are different things that 2D shapes have. Now, please write this down. 2D shapes have namely 2 different things. Number 1, they have sides and they have something called vertices. Vertices or a vertex is the corner of the shape. Vertices are also in 3D, but they are more visible when it comes to 2D to say, no, here's a vertex. When there are many, there are vertices. And on top of that, when we are dealing with 2-dimensional shapes, we talk about size. How many sides does it have? How many sides does it have? Then we're talking about 1, 2. If the rectangle is 1, 2, 3, 4. Literally, we are counting the sides of it, not the face or anything, but the sides. Understand? On the other side, you see there'll be a point where you're counting edges and faces. I should be counting the sides because for all 2D shapes, if you're saying looking at faces, 2D shapes only have 2 faces. But by the vertices and sides, they'll be different. By the vertices and sides, they'll be very different. Right. So please write this down. Characteristics of 2D shapes. I'll give you a few minutes to do it. Saying how many sides and vertices does a square have? How many sides? So a square has 4 sides, 4 vertices, which is true. A circle, no sides, no vertices. Triangle, 3 sides, 3 vertices. Pentagon is 5 sides, so it's 5 vertices. Hexagon, 6 sides, 6 vertices. Heptagon, 7 sides, 7 vertices. Octagon, 8 sides, 8 vertices. Nonagon, 9 sides, 9 vertices. That's how you identify it, by the sides and its corners. by the sides and its corners. Simple as that. Simple as that. About 2 minutes left. About 2 minutes left. About 2 minutes left. Please have this down in your books. About 2 minutes left. If your video is on, please switch it off. If your video is on, please switch it off. If your video is on, please switch it off. Got some short time remaining. Those who are done, please notify me in the chat. Those who are done writing it down, please notify me in the chat. You use the technology to screenshot or some. So those who are done, please notify me in the chat if you're done having the information with you. About a minute left. About a minute left. Yes. About a minute left. As I always say, take advantage of the technology. But you have about a minute left. About a minute left. A minute left. 1 full minute. 60 seconds. 60 seconds. 60 seconds. 60 seconds. 60 seconds. I see that most of us are done, but you have 60 seconds left of the slide. We can make it out. 60 seconds. Twenty seconds left. 20 seconds left. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Next slide. Now, in geometry, a three-dimensional shape can be defined as a solid figure, a shape that has 3 dimensions, which is length, width, and height. Unlike two-dimensional shapes, three-dimensional shapes have thickness and depth. So three-dimensional shapes are those shapes that you can actually handle. Like if you want an example of a cube, look at a box. You can actually hold it. It's not flat. You can actually hold it. You can put something inside it. That's why many things that are made out of three-dimensional shapes are actually shapes that can be used to hold as containers or something like that. So three-dimensional shapes are able to have a thickness and depth. And one thing about them, what makes them three-dimensional is that of 3 dimensions. So they have length, they have width, and they have height. So it's what? Length. So you can look at it either way. You can be saying, okay, there's length, there's width, and some people say depth. Some people say, no, there's length, there's width, there's height. But you have 3 dimensions and it is thick. It is, you are able to manipulate it much more easier. So let me give you guys time to write down this definition. Let me give you enough time to write down this definition. The time has started. You have 2 minutes on the dot to write down this definition. 2 minutes on the clock. 2 full minutes on the clock. So a three-dimensional shape can be defined as a solid figure. It's solid, so you can hold it. Two-dimensional is flat. So it's not as easy, but yeah, it's a completely flat object. That's what makes it two-dimensional, because it only has 2 dimensions. This has 3 dimensions. 3 dimensions. 3 dimensions. Almost a minute left. Almost a minute left. Almost a minute left. Almost a minute left. One minute remaining. 1 minute remaining. 1 full minute remaining. 1 minute remaining. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So the shapes that you meet are a sphere, a cylinder, a pyramid, a cone, a cube, a triangular prism, a cuboid. What I want to focus on is the faces and the vertices. So if we look at a square pyramid or a square-based pyramid, we can see, okay, how many does faces does it? 5. So it's what? 1, 2, 3, 4, 5. A face on a 2D object is actually the one. A face on a 3D object is actually one 2D object. That's how we count faces. So each 2D object we see there counts as a face. And then the edge is where 2 faces meet. So you see right here, where 2 faces meet is what we call an edge. Then the vertex is the corners. The vertices is the corners. So a face is of a 2D object, 3D object is the 2D object that makes up it. All the 2D objects that make it up count as the face. The edge is where the 2D objects meet. So wherever they touch, it's called an edge. And then the corners of the shape, all shapes, is what called vertices, or they are called vertices. So please write this one, this one, this one, this one. Please write about the square pyramid, the cuboid, the triangular prism, and the hexagonal prism. Please write it down. Square-based pyramid, the cuboid, the triangular prism, and the hexagonal prism. Please, 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 let us write quickly so we can cover majority of the work while there's still time. So please write number 1, number 2, number 3, and number 4. Number 1, number 2, number 3, and number 4. Quickly. You have 2 minutes. You have 2 minutes to write number 3, number 2, number 1, number 2, number 3, and number 4. You have 2 minutes. 2 minutes in counting. So please write number 1, number 2, number 3, and number 4. Number 1, number 2, number 3, number 4. Number 1, number 2, number 3, and number 4. "50 seconds left. 50 seconds left. "30 seconds left. 30 seconds left. 30 seconds left. I'll take a question. I'll take a question.
Sir, I
Hello?
wanted to tell you, sir,
Yes.
halfway through this lesson, sir, I didn't really understand that much, sir,
Didn't
because
understand?
I couldn't understand that much, sir, because my connection is very bad, sir. Now it's glitching, so I can't hear it properly, sir.
All right, then you'll just have to watch it on YouTube. The video will be posted on
Okay,
YouTube.
sir.
All right.
Okay, sir.
All right. Are we done? Are we done? Are we done? I think we are done writing this. Let us go here. So, I want us to actually cover this. Now, the line of symmetry can be defined as the axis or imaginary line that passes through the center of the shape or object and divides it into identical halves. So when we speak about a line of symmetry, we're speaking about a line that if I were to cut the 2D shape, the triangle this way, and fold it, the left-hand side and the right-hand side would fit into each other exactly. If I were to fold it that other way, the right-hand side and the left-hand side would fit in each other exactly. That is what a line of symmetry is. Symmetry is saying that the left and the right, when folded, will match. That you won't see it overlapping or anything. That's why lines of symmetry work in what we say regular polygons. We call them regular polygons. Regular shapes meaning that all the sides are like all the sides, most of the sides are equal or such like that. So when you are looking at a regular shape, not a shape where one side is big, the other one small, and looks very different, you find that you find that it's not symmetrical. But with a symmetrical shape like here, even if you were to take this part of the triangle, the rectangle and fold it that side, you'd find it that it fits to each other exactly to make some form, that's actually a square, some form of a triangles on top of each other. So that is symmetry. Symmetry is the ability to actually go through it, put a line through and say, no, if you cut it through here and fold, it will become, the left and the right would match each other exactly. If we're to go this way, the left and the right would match each other exactly. That's what we call symmetry. Lines of symmetry. Because you keep on making identical halves. Keep on making identical halves. So please write down this information. You have 2 minutes. 2 minutes to write down about the lines of symmetry. So it's a line that you put through the shape, either this way, this way. But at the end of the day, when you see that, if I was to be cutting it, because this means if you cut it this way, it folds left and right, it fits exactly. You cut it this way, folds like that, fits exactly. An exact fit. An exact fit. One minute, 10 seconds. One minute. Please write, 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 please write. Please write, please write, please write, please write, please write, please write. 40 seconds left. 40 seconds left. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time up. Can I please have notification in the chat who is done writing? Who is done writing? Who is done writing? Who is done writing about the line of symmetry? Please, can I be alerted? Who is done writing about the line of symmetry? When something is, symmetrical. Beautiful. Beautiful, 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 beautiful. Right. Right now, I would like you guys to try out this exercise for about try number 1 and number 2 here. This would be number 1, this would be number 2. See how many lines of symmetry they have in 2 minutes. And then we talk about it. How many lines of symmetry they have in 2 minutes. Your 2 minutes starts now. Let's see how many lines of that they have. Looking at the first shape and the second shape. How many lines of symmetry do you think they have? How many lines of symmetry do you think that they have? How many lines of symmetry do you think they have? The first one and the second one. The first one and the second one. How many lines of symmetry do you think that they have? Number 1 and number 2. How many lines of symmetry do you think that they have? Number 1 and number 2. Number 1 and number 2. 50 seconds left. 50 seconds left. 50 seconds left. How many lines of symmetry do they have? How many lines of symmetry do they have? Looking at number 1 and looking at number 2. How many lines of symmetry do you think that they have? How many lines of symmetry do you think that they have? How many lines of symmetry do you think that they have? All right. Who has our answer? Who has our answer? Who can answer this for us? Who can answer this for us? Hello?
Hello, sir.
Hello, how are you?
I'm fine. Thanks, and you, sir?
Awesome. So how many lines of symmetry does the first one and the second one have?
So I think the first one has 2 lines of symmetry.
All right, which is where?
Across and downward.
It's like this and like this.
And yes, sir. And then the second one has 1 only going down.
So only this. All right. All right. Thank you so much. I would say this is a triangle and it's able to even go this way. And this way. Because it's a triangle. Right? I want for number 1. If someone has found more for number 1. Hello?
Sir, yes, I have found more for number 1.
Yes.
So, Bulel, how do you say her name?
Yes.
And anyways, she found two ways it could go,
Yes.
and it could also go 2 ways across.
So from here to here.
Yeah, and then the other top, and then another way,
All right.
and then the other side.
And like this.
Yeah.
All right. All right. All right. All right. All right. Thank you so much. Thank you. Thank you. Thank you. Thank you. Thank you so much. Right. All right. I'll quickly explain what a net is. A net of a 3D object is when you lay it out flat, right? So when you break it up, but we'll go over this tomorrow some more, of a 3D object and you make it up into a net, it's when you make it flat and you show every 2D object that makes it. So when you make it up flat and then you show, like, for example, this was a triangle-based pyramid. So you just opened it up and you showed each and every triangle that made up this whole shape, this whole 3D shape. But that is fine. Here is your homework, right? Homework is define the following: vertex, line of symmetry, face, edge. Then you look for 6 3D shapes and draw the net of each shape. You look for 6 3D shape and you draw the nets of each shape. Do we have any questions? Do we have any questions? I will go further on the part about nets tomorrow because we could not completely go through it. But do we have any questions?
Yes, sir. My question is like not much of a question, but
Yes.
like we send this to you through your email, or like we send it to you on like an app or something.
You can send me the homework to my email address.
Okay, you're going to show us now.
Or my email address. I'll put it in the chat.
Okay, thank you.
Awesome.
Sam, you had given us homework yesterday.
Yes.
Are we gonna mark it, or I'm not sure?
I have already gone through it, but because we need to cover more content, I I will respond back per email.
Yes, sir.
So I'll respond to you in the email.
Yes, sir.
All
Thank
right.
you, sir.
Awesome. I hope we're done writing down the homework, right? Let me just show you guys my email address. It's the next slide. Right. Here is my email address, longwaychiponosio@gmail.com. Here is my email address, longwaychiponosio@gmail.com. Thank you guys for being an amazing class. Thank you guys for being fantastic. I will see you guys tomorrow when now we finalize everything. Thank you guys for being an awesome class. Please do your homework. And yeah, I hope you guys will be ready for next week's test. But for now, I'm sure you are. So thank you so much. Goodbye. Goodbye.